So one of the factors I can measure is soil moisture. Now, where there is a higher soil moisture content, we might expect there to be a slower infiltration rate and maybe higher amounts of surface runoff, so the water will reach the river quicker. And on this slope that I'm stood at now, the soil moisture content might be different. So where the gradient is steeper on this slope, I would expect there to be a lower soil moisture content. And where the gradient is more flat at the bottom of the slope, I would expect the soil moisture content is higher, as most of the water is run down the slope and gathered here. So one bit of equipment that we can use to measure the soil moisture is this thing here called a soil moisture meter. Now these are quite easily available in most garden centres. If you've got people at home or yourselves are quite into looking after your plants and knowing how much moisture is in the soil, you might have one of these already at home. It's super easy to use. All you need to do at your sample site is place it into the ground and take a reading. Now, as we can see today, it is July, it's very sunny, and we're also on a slope. So the reading's very low. In fact, it's barely reading at all, which is a bit of a problem for our investigation. Now, with the soil moisture probe, you want to make sure ideally that the probe is covered by the ground. However, where the soil is very compact, that's not always possible, so it might be a little bit of a limitation. When I take the reading of the soil moisture meter, I will get a reading up between 1 and 10, 1 being dry and 10 being wet. So that's more of an arbitrary value. It's not giving me the absolute soil moisture content. So to do that, I'm going to need to collect an actual sample of soil, or several samples across different locations depending on what I'm investigating. Now, to get my sample, I'm going to use this instrument here called a soil auger. Now, a soil auger is really useful because it allows me to take a sample of soil from the ground without damaging the surface too much, which is really important if we're within Exmoor National Park, like I am now. The other thing the auger does is allows me to get a soil sample from a set depth. So my set depth can be controlled across my different sample sites. Cut. So now my soil auger has gone all the way into the ground. I need to collect my soil sample. And to do that, I need to have a small pot ready, or I might have a small plastic bag or a sandwich bag lying around the house that I could use to collect the sample in. So I'm going to carefully take my auger, take it out, and hopefully you'll find that a lot of the soil has managed to stick to the auger. And because we want to make sure that our auger is enabling us to collect our soil sample from the same depth, what we want to do is then take a sample from the very bottom of the auger and place it into the pot. If I'm collecting a lot of soil samples, what I will want to make sure I do is label the top of my pot or the sandwich bag so I know where I've collected my sample from. You'll want to make sure the pot or the bag that you're collecting your soil in is sealed, because what you don't want to happen is when you take your soil back to analyse it, you want to make sure that none of the water has evaporated. Now, you might not have access to a soil auger, but that's okay because you probably have access to one of these, trowel. Now, obviously, a limitation of using the trowel is that you might not be able to get to the same depth as your soil auger, and you might be able to create more disturbance to the ground, but you can still find a way of controlling the depth that you're taking your soil sample from, and it's still very useful. So to calculate the actual percentage soil moisture of our soil, it's actually pretty simple, and all I need is my soil sample that I collected earlier, a pot or a crucible like I have here, and a microwave. So the first thing I'm going to do is weigh the crucible or my pot and record that weight using the scales. Okay, so I've got 17.37. The next thing I'm going to do is I'm going to take my soil sample, put it into the crucible, and then I'm going to weigh my soil sample. Okay, so my soil sample in the crucible is now 20.46 grams. Now the next thing I need to do is actually pop it in the microwave. Now, if I've got more than one soil sample, it might be useful for me to label where my soil sample is from, otherwise you might lose track of what soil sample you're looking at. And I'm also going to put it in the microwave with another pot that's just full of water. And the reason for that is just because I know that when this water's evaporated, I know that all the water has evaporated from this soil sample too. So I'm just going to put it in the microwave. So now my water is all evaporated from one crucible, I can be confident that the water is all evaporated from my soil sample. So all that's left for me to do now is reweigh my sample. And now I can see my figure now is 20.01. And then I would use a calculation to work out my percentage soil moisture content.